Welcome to 2.2, the angles of a triangle. We're going to go over angles, the type of angles for a triangle, and more special relationships to help you determine missing angles. And we'll also go over some example problems. So the first thing I wanted to go over was the proof of angle sum theorem. This states that the sum of the angle measures add up to 180. So angle B plus angle angle B, angle A plus angle C, they will all add up to 180. Okay, now how do we know that? Let's try to prove it. So why don't we imagine we have another line coming through here, and let's call this line DE. And you notice that this line segment AC, is parallel to line DE, right? Because if you imagined AC to continue on, you can tell that it is parallel to DE, right? So we know that segment AC is parallel to line DE, okay? What else do we notice? Well, you can see that segment AB, if it continues on, it is actually a transversal, right? And we already learned about transversals and the special pairs of angles that it can create, right? Remember we talked about, alternate interior angles. So here, this angle here, which is on the outside of the triangle, is congruent to angle A, okay? So we can say that this angle on the outside of the triangle, the exterior angle, is congruent to angle A. Okay, what else do we notice? Well, segment BC is also a transversal if it continued on. It also looks like a transversal. Remember, a transversal cuts through parallel lines, okay? And again, going back to our special pairs of angles, we also see another pair of alternate interior angles. Okay, so this exterior angle is actually congruent to angle C. Why is this important? Well, this is a straight line. And now we can see that this angle, angle B, and this other exterior angle, they are adjacent to each other, and they add up to 180, okay? Because this is congruent to this, and this angle is congruent to this angle, and since they are all there, you see the straight line, they add up to 180, and this proves that the sum of the angles inside a triangle will add up to 180. Okay, so now let's look at an example. This asks you to find the measures of angle A and C, and we are representing angle A and C with these algebraic expressions. Well, how do we do that? Well, we can already apply the angle sum theorem we just talked about. So we know that angle A plus angle B plus angle C should equal to 180, okay? Well, how do we represent angle A? Well, it's represented as 3x in this example. Angle B is given, the measure of angle B is given, and angle C is represented by 2x plus 10. And this should all equal 1 to 180. Now we can combine like terms and simplify further. 3x and 2x gives 5x. 70 and 10, these are just constants, so this should give us 80 equals to 180. Now we can solve for x, and we need to do that by getting x by itself. So let's subtract 80 from both sides. So this gives us 5x equals to 100. Now we can divide by 5, and this should give us x equals to 20. But we're not done yet, because angle A and angle C are represented by some algebraic expression where x was our unknown. But now we found x, so we can plug this in to each of these expressions. So that means angle A equals to 3x, but instead of x, we know x is 20. So angle A is actually 60 degrees. Angle C is 2x plus 10. And instead of x, we'll plug in 20 because we know x is 20. And this should give us 50, okay? Now let's double check. Does this still add up to 180? Well, we know angle A is 60. I'll write it over here. Angle A is 60. Angle B is 70. Angle C is 50. 70 plus 50 is 120. 120 plus 60 is 180. So yes, we solved for it correctly. So that is a way to check your answer if you're unsure. So the measures of angle A and angle C are 60 degrees and 50 degrees respectively. Now let's get into this third angle theorem. This states that if two angles of a triangle are congruent to two angles of another triangle, then the third angles are also congruent, okay? So our first triangle of a triangle would be our orange one. And what is the other triangle? It would be our green one. We see here triangle. Okay, we can see that this angle is congruent to this angle in a different triangle, and this angle is congruent to this angle in another triangle. So because we know it should sum up to 180, and these two are already congruent to another angle, to other angles in another triangle, then the third and last angle should also be congruent, because remember, the sum of the interior angles have to add up to 180. So if these two numbers are the same, this number should give us a number where we add it up to give us 180. So this would be 50. And this should also be 50 because 70 plus 60 plus something has to give us 180, and that would be 50. So this third angle theorem just states that if two angles in one triangle are congruent to two other angles in another triangle, then the third angle also has to be congruent. And we know this because of the angle sum theorem. So this whole time, we've been talking about interior angles, but there is actually another type of angle, and they're called exterior angles. These are angles that are on the outside of a triangle and form linear pairs with interior angles. So let's break down what that means. So all the angles we've talked about are interior, so on the inside, right? But you have to keep in mind, we also have exterior angles, and this would be on the outside, okay? So they are on the outside of a triangle and form linear pairs. What are linear pairs again? These are adjacent angles that are supplementary. So they form linear pairs with interior angles, okay? Another thing to keep in mind is that for a triangle, there are 6 exterior angles in total. So there's one here. If we were to continue segment AB, if we continue segment AC, we would form another exterior angle here. And if you just focus on this line, you can see that this exterior angle forms a linear pair with this interior angle. Because of this line, these two should add up to 180. Because of this line, these two should add to 180. And this will be the case for all the 3 vertices. If it just continues on, here's exterior angle, exterior angle, exterior angle, and another exterior angle. What do you also notice about these exterior angles? Remember, if you zoom in, these two lines are intersecting, and these two angles are vertical angles because they are on opposite sides. So they should also be congruent. And why is this important? Because let's pretend this was 100. This means this also has to be 100. And let's pretend that this is 80. This makes sense because here, the exterior angle has to form a linear pair with the interior angle, so they add up to 180. Similarly, this exterior angle has to form a linear pair with this interior angle, And that makes sense why these two should be the same, because no matter what, they need to add up to 180 because they are a linear pair. Now, because of exterior angles, we also have remote interior angles. These are the interior angles that don't touch. That means they are not adjacent to the exterior angles. Okay, so if we look at our triangle again, so in this case, here's our exterior angle. For this particular exterior angle, it has two remote interior angles. What does remote mean? Remote just means distant or far away. Okay, so this exterior angle is adjacent, or it's touching this interior angle. So that means these two interior angles are considered the remote because they're not touching the exterior angle, they're far away. And yes, that's all you need to know. But what is the significance? Well, again, this goes back to the special relationships and how you can use the special relationships to solve for missing angles, right? Well, this actually goes to our proof of exterior angle theorem. This states that the sum of the two remote interior angles, so in this case it would be 2 and 1 for exterior angle 4. So the sum of these two remote interior angles, it will be equal to the measure of the exterior angle. How do we know that? Well, let's pretend that this angle 3 was 60, okay? Oops. 60 degrees. What did we already learn? We learned that the exterior angle has to form a linear pair with the adjacent interior angle, okay? And remember, linear pairs add up to 180. So 180 minus 60 is 120. So angle 4 has to be 120 degrees. Now this states that the sum of the two remote interior angles is equal to the measure of the exterior. So this means if you add angle 2 and angle 3, this would give us angle 4, okay? Now how do we know that? Let's prove it. Well, what do we know already? Like I said, we know angle 3 plus angle 4 have to be equal to 180 because they form a linear pair. Now what else do we know? Remember, the angle sum theorem states that the sum of the interior angles of a triangle has to add up to 180. So we know that angle 1, angle 2, plus angle 2 plus angle 3 equals to 180. Now we can do the same thing what we have done for other proofs. We can substitute another expression in, okay? So instead of writing 180, I'm just going to substitute this expression because my equation here tells me that 180 equals to whatever this is, okay? So I'm going to rewrite angle 3 plus angle 4 equals, and instead of writing 180, I'm just going to substitute it for this expression. Angle 1 plus angle 2 plus angle 3, okay? Now we see angle 3 is on both sides, so we can just subtract to get rid of it. Subtract angle 3. So it will cancel out. So what are we left with? We're left with angle 4 equals to angle 1 plus angle 2. So this proves the exterior angle theorem, which states that the sum of the remote interior angles will equal to the exterior angle, right? Angle 1 plus 2 equals to angle 4. Now let's get into some examples. This asks, what is the measure of angle 2? Well, what do we already know? We know that this is an exterior angle, and its remote interior angles would be 1 and 2. We know that this is an exterior angle, and it should form a linear pair with the adjacent interior angle, okay? So if this angle 1 plus 90 equals to 180, then we know that angle 1 should be 90, okay? And what did we also know? The exterior angle is equal to the sum of these two. So we know that 130 equals to sum of angle 1 plus angle 2. Well, we already solved for angle 1, 90 degrees. And now we can just simply solve for angle 2, okay? So that should give us